In the previous video, we talked about exponent laws with powers of 10. Now let's see how exponent laws can work with questions involving scientific notation. So we're going to do example A fully together. Express each value in scientific notation first, and then use exponent laws to calculate, and then finally report the answer in scientific notation. And we'll round the coefficients to the nearest hundredth. So turning 9,070 into scientific notation gets us 9.070 times 10 to the power 3, and 0.806 in scientific notation is times 8.06 times 10 to the negative 1. Now we'll group the number portions together and then the powers of 10 together. So 9.070 times 8.06 times 10 to the 3 times 10 to the negative 1. And we'll do this multiplication in the calculator to get 73.1042. And powers of 10. When you have multiplication of the same basis, you just add the exponents. So times 10 to the power 2. 3 minus 1 is 2. Now we want to report the final answer in scientific notation. Notice the 73.1042 is not a number between 1 and 10. So we're going to work with that. We're going to take that number itself and change it into 7.31042 times 10 to the 1. And we also had that times 10 to the 2 at the end. And we'll combine these powers to get an answer of 7.31042 times 10 to the 3. And we'll pay attention to our rounding instructions. It's set to the nearest hundredth. So the 3 is the tenths, the 1s is the hundredths. The 0 to the right of it does not bump the 1, so our final answer is 7.31 times 10 to the 3. So take a minute now, copy down this next question, or work through it, pause the video, and come back whenever you're done to check on your full solutions and answer. So I hope you were able to follow the same steps or similar steps as part A for question B and come up with this final answer, and hope you have a better understanding of how exponent laws can work with questions involving scientific notation.